next class is all about torque and angular momentum and conservation of angular momentum. And the next class is going to be the MI. MI stands for moment of inertia. So these are the few important basics, and then in the next class we are going to talk about pure rolling motion. Okay, so in this way we are going to finish this chapter. If you have any question, query, anything from the previous class, center of mass of cavity, center of mass of continuous thing, center of mass of non-continuous thing, or you can say discrete system, or rigid body definition and rotation and anything, so you can ask. If you don't, so we can go ahead. Clear? Okay. So like we did this thing, so it is a recall. Motion of center of mass of already there. So motion of center of mass states that if we have a center of n number of particles, because it is n number of particles, and what it is, if we have any particular body, okay, and for any particular body which is, you can say in this way, discrete enough, and we have these much particles, so we need to find a center of mass, which is going to be assumption, or it is a point which is going to be at the center. So first the thing, we need to find center of mass. So you can see this is position of center of mass. Position of center of mass basically from this origin, from where we are going to find everything. Okay, this is your origin. This is suppose the point of center of mass. And once we find the center of mass, so we can find the velocity of center of mass just by doing the derivative. Okay, so that we already done in the previous class. So to find the, or you can say velocity of center of mass, to find the velocity of center of mass, we differentiate equation. We differentiate equation 1 with respect to time. So this is velocity of center of mass in simple sense, and that is m1, and you can say m1 v1 plus m2 v2, because dr1 by dt is v1, dr by d2 by dt is v2, dr3 by dt is v3. In a simple sense, that is vcom m1 v1 plus m2 v2 plus m3 v3 plus divided by m1 m2 m3, and you can say the total mass. So this equation is important. In a same sense, if we know the velocity of center of mass and we want to find the acceleration of center of mass, so what we are going to do, we are going to differentiate that equation number second again, and we can get acceleration of center of mass, that is nothing but m1 a1 m2 a2 m3 a3 divided by the total mass, which is m1 plus m2 plus m3. Clear? Okay, so that is the main thing. Now momentum, or quantity of motion and impulse. So in this class, I don't think so you get something which is not you already know. Maximum things you know, because I already teach a lesser, I mean not lesser, you can say more than whatever it is written on the PPT. So I think I already given most of the stuff going to discuss in this class. So you can take this class as a revision class of yours. And if you want to ask any deeper question on this given topic, subtopic, so you can go ahead also. Okay, clear everyone? So I mean nothing is going to, one more thing. Good, I get to share this thing. See, there is very simple thing. I check your weekly test, or you can say fourth weekly test. So if you have any particular questions, or you can say which is subjective question. So how you can find subjective question? Because what I get, few students, I'm not going to name, give the answer in a proper manner. Okay, like they, I mean automatically they get to know to whom I'm talking right now. So few students attach the questions properly, 4 marks, 5 marks, 6 marks, or you can say, or few students did the derivation in an appropriate manner. For example, there is a derivation in which we need to prove. So obviously whenever we need to prove, so we cannot write just the same thing. Okay, and few students doesn't do this thing. So I want to ask to you guys how you can find that is a subjective question and you do in an appropriate manner. And if you don't find, so is there anything which is written on the paper like there is a subjective question, or is this the 4 mark, 5 mark? Because few students did in a right way and few students doesn't do in a right way. What is the right way? If it is a subjective question, you can say 1 question, 2 question, 3 question, or in a single question there is a sub part 1, 2, 3. So you need to attempt all 1, 2, 3 and you need to write a little bit about each particular part. You cannot write just answer. Okay. So the students who doesn't do in this way, the way we say right way here, needs to do, because basically the 4th test is each particular month. The 4th test of yours is going to be in a subjective way, the way in which boards accept the answer. Boards means you are in 11th class right now. In the next class, 12th class, you are going to opt, you are going to sit for a boards examination. And obviously you need to know how to write in theory, right? Like proper derivation, proper this is given, this formula is used. So few students write in a appropriate manner. So obviously I give the number to them in that particular manner, and few students just write the answer. Suppose there is a derivation and you just write hence prove x equals to something, y, z and so, or you can say 4, 5 and 6. So that is not going to be given any particular number, right? And suppose there is a, you can say 3 subparts and you just write the answer of 3 subparts. For example, in the first part I am going to ask, suppose I give you a force is something so and so and kinetic energy and so and so, and then I ask find this acceleration, momentum, and you just write this mass equals to this, momentum equals to this, and this equals to this. So obviously this is 4 mark, 3 mark questions. So being a, you can say tutor and a teacher, I cannot give whole 4 marks to you. 1 mark, 2 mark just to write answer, just because you write something. 1 mark, and sometimes I give 0 also because there is a subjective. So from you I want to know, is this something you guys get to know that is a subjective, or is there is a misconfusion or misunderstanding, like each particular question you get in a same appropriate template. What is a template? Like this. Obviously if there is a MCQ, so automatically the question is going to be MCQ. It is a 1 mark. You just need to write the answer, and if you write the steps also, that is very good. That is shows you are doing by yourself. But even if you write the answer, so we can, we are bound to give you a number, being a teacher or being the examiner or a checker. But if there is a subjective question and you don't write the steps and you don't write in a appropriate manner, so we are not going to provide the number. I am sharing this much because when the PTM is going to be happen and whosoever is going to take your PTM, so don't mind and don't say these words like sir or ma'am, whosoever going to take your PTM, we write the answer for each particular thing, but our marks is not according to the manner what we given in the answer sheet or what we given in a format. Got it? So stick to this thing in your head. The 4th test of each month is a subjective one, and that is deliberately we put just to make a practice of yours, just to make a practice of each particular student here, so they can do a little practice about this subjective thing also. Clear na everyone? Good. So momentum, what is momentum? That is a quantity of motion and a physical quantity which define about the motion of any particular object. So Newton defined that the quantity of motion or momentum P to be product the mass of the velocity and the mass and the velocity. Momentum is a vector quantity obviously because velocity is a vector quantity. With the direction and magnitude, the direction of momentum is the same as the direction of the velocity because mass is scalar there. The magnitude of the momentum is the product of the mass and the instantaneous speed, or you can say velocity. Unit, the SI unit of system, you can say the SI system of units of a momentum is kilogram meter per second because it is simply P equals to mv, and we have unit of this velocity is meter per second. So that is why it is kilometer per second, nothing more in this. Clear? Clear na this thing? Okay, so the next thing is the linear momentum of system of particles. So in this particular chapter, we discuss system of particles. Basically, every particular rigid body, as we know, it is made up of n number of particles. Okay, you can think of in this way, or a stone, this particular stone is made up of so many number of particles. Okay, and you can say there are different masses and there are different velocities even. So when we have a different masses and different velocities, the product of each different thing is going to be the different, and the momentum is going to be the different also. Clear? So Fi is basically the initial, you can say, force. It is external plus the summation of all Fij. So suppose we have a n number of system of particles, n particles labeled by the index I 1, 2, 3 to n. Therefore, the force on the ith particle. What does it mean? Suppose I pick this particular particle in this way. This I can assume the ith particle. So first of all, first I have n number of, I can choose I 1 to n anything. Okay. Then on this particular particle, the force is going to be two kind of force. So you can say two forces. Any particular force which I apply from the external sources. Suppose this is. Suppose this is the external force. Fi external. Fi external means the external force on the ith particle. And what this I j equals to 1 to n ij stands for, due to this disturbance. Due to this external force, it is going to disturb, it is going to change the position a little bit, right? It is going to change the position a little bit from here to suppose here. So due to this disturbance, the effect on other particles, suppose j equals to 1 to this, got it? Due to this particular particle on this, due to this particular particle on this, due to this particular particle on this, due to this, due to this, due to this. Because the arrangement is going to be a little bit hamper, and this, when this arrangement is going to be a little bit hamper, so effect of this arrangement, or you can say force due to this I motion, or due to you can say force which is internally also, and you can say the effect of other particles on this, and the force we applied on the particular particle. So that is the net force on this. Okay, so due to this internal, we have this much. Basically, on I, if I apply any external force anywhere, so at this particular point, I can say ith particle. Okay, so due to this internal force, this particular is the internal force, and this internal force is nothing but the effect of net force on the ith particle. Or you can say the total force on the ith particle, we can subdivide it into two categories, into two parts. Any external, which is we deliberately apply, and the effect of this external and due to the other particle. So this internal force is basically we are going to discuss, and this is the system. This in this way, this is going to be the momentum of system, which is Pi1 plus Pi2 plus Pi3 and so and so. Is this clear? And that is going to be you can say conserve also. So how it is, where what it is, we are going to discuss. Clear na this thing? So as you can read out in this expression, Fji, j cannot be equals to I, because I cannot apply any particular effect on himself or itself. So Ji is the force on the ith particle due to the interaction between I and j particle. We sum over all jth particle with j never ever equals to I or j not equals to I, since a particle cannot exert a force on itself. Equivalently, we would define Fii equals to 0. Either you can write in this way or either you can write in this way. Yielding the internal forces acting on the ith particle. So that is my internal force on I particle. from any other J particle. J can be 1, 2, anything, but not I. Okay, if you say this is the second particle, so then J can be 1, 3, 4, 6, 7, 8, 9, but it cannot be 2. Clear? Okay. So moving ahead, the force acting on the system is sum over all I particles of the force acting on each particle. So the net particle, I mean you can say the net force. The net force is going to be I equals to 1 to n, because we have n particle, and this net force is going to be I equals to 1 to n, whatever the external force we apply, and whatever the I equals to 1 to n, J equals to 1 to n. This is a little bit confusing, this second term, but you can suppose right now I'm just talking about I equals to 2 particles. But someone says, sir, I am not willing to apply external force, I equals to 2. I want to pick I equals to 30. Then another student can say that, sir, I want to pick this I equals to 7. In this way, we can find the net force, isn't it? And due to the effect of these net force and the interaction between them. Got it? Because it is not, fixed that I can choose I equals to only 2, I equals to only 3. It's I need to find the net force. And how can I find the net force? Whenever I pick I from 1 to n and then do the summation. And due to this 1 to n, when I'm doing the summation, there is an interaction also. Got it? So the net force on this rigid body system, which is the, you can say, rigid body is basically the system of n particles of mass different, of spacing different. So we do this thing. So the net force, this is your basically the net force on rigid body. Okay. So the force acting on the system here is basically, system is the sum of over all I particle of the force acting on each. That is, you can say the force, or you can say the net force acting on rigid body also. I can write net force acting on rigid body, because rigid body is made in this way. Okay, made up in this way. Clear? So this is the net force. Note that the double sum vanishes. Why it is vanishes? Because it is internally force. So internal force is going to cancel each other. What does it mean? Back to this. Suppose this is going to apply a force on this. So this is going to apply a force on this also, somewhere, another particle. And this is going to apply a force on this also. So they are cancelling each other, because the direction of force is going to be reverse. Suppose in this way, you just suppose this is force, this particle apply force on this, and this same particle is apply force on this. So there are two forces, very minute, this one and this one. They are going to cancel each other. Clear? So that is how they are vanishing, and that is why we can vanish internal force. Clear? Means you can assume in this way, if you going to shake any particular thing. Okay, suppose you put a pulse or mix a pulse in some jar and you shake like this. So what is going to be happen? The pulse is going to be mixed in that appropriate manner, so you cannot find which is going to be which pulse. If you pick n number, or you can say different kind of thing. Okay. So which particular pulse apply the force on another kind of pulse, it is not going to be visualized, or it is not going to easily find. Why? So because the net force, whatever the one particle is applying the force on another, it is going to cancel, because they are almost same mass. But if I'm going to do in this way, I mix a sand or any particular nut, so they are automatically you can find, or you can separate them by the hand of your semen. But if you mix a sand with a salt, so the sand particle and the salt particle going to be mixed, going to interact with each other in this way, the internal force with them is going to be cancelled out. Got it now? Like simply a mixing thing. So this is going to be, I mean, note that the double sum is going to vanish because internal force is going to cancel each other. You can write in this way: internal force going to cancel each other, or internal force cancel each other. So that is why net internal force is going to 0. So that is why Fji equals to Fij 0. The force on the ith particle is equal to the rate of change in the momentum of the ith particle. Fair enough, because we learn this thing from the second law of Newton's. Any particular force is rate of change of momentum. Simply. Clear? So then Fi, which is dpi by dt. Okay. Simple thing. So when can now substitute equation 6 into equation 3rd, means F external, which is I to n, and which is equation 3rd. This is equation 3rd. The second, or you can say due to equation 4, the second equation, third equation is already converted into, this is using equation 4. Okay, just a minute. Using equation 4, equation 3rd, we can rewrite, and that is this. So equation 3rd, which is the net force F, is going to be only and only I equals to 1 to n. I am going to write, okay, and that is Fi external. Clear? Clear na? This one, or you can say I, and simply summation I equals to 1 to n, and then this is the net force. So this one is new third equation. Clear now? So this is my third equation now. What we are going to stick on the next page. So we, when can now substitute equation number 6 into equation number 3 and determine that the external force is equal to the sum over all particles of the momentum change particles of momentum change of each particle. So F external is dpi by dt, and that is my momentum of a system. As simple as that. Okay, so we are doing nothing, but the manner we are finding R center of mass. R is position of center of mass. You can say M1 R1, M2 R2, M3 R3, and divided by total sum. In the same way, we can find the velocity of center of mass, M1 V1, M2 V2, M3 V3, and divided by the net sum. In the same manner, we can find the acceleration of center of mass, M1 A1, M2, this and that. In the same manner, we can find the momentum of a system of particle, the net momentum, P1 plus P2 plus P3 plus P4 plus P5, and so and so. Clear? Clear na? And if you have that, you can say in your head right now, where it is going to be, why it is going to be related to the external force, and where the internal force is going to be. So internal forces balance each other, they cancel each other. As simple as that. Okay. So whenever we apply an external force, so that external force is nothing but the rate of change of n number of particle of momentum. So if we want to find the momentum of the entire system, so you don't need to do anything, that you just need to sum the momentum of each particular particle over there, whatever the body is going to represent. Clear? That is your momentum of system. Then momentum acts as a vector, obviously. So we conclude that the external force causes the momentum of the system to change, and we thus restate the generalized Newton's second law for a system of object as F external is dp system by dt. What does it mean? As we know, like Newton's second law is what? Directly proportional to this, and this proportional sign becomes 1, or you can say, just a minute, this is F equals to K rate of change of rate of change of momentum, and here proportionality sign K is 1. Okay, that we know. So simply force is rate of change of momentum, what we know. So for a system of particle, whenever we need to or whenever we are going to apply an external force, so that is rate of change of system of particles. Instead of taking one, we can take all together. As simple as that. In terms of impulse, this becomes the statement. So impulse, what is impulse? First of all, this is also known as impulse. So beta, impulse in general, you hear this terminology so many times, that particular person have impulsive nature. What does it mean? Impulse is basically the large amount of force, or you can say high amount of force for a very small interval of time. Clear? So that is impulse in general. In simple word, impulse I, large amount of force, large amount of force for a short range of time, for a short span of time in general, short span of time, in simple sense. And that is why mathematically also, that is why we represent impulse I equals to rate of change of momentum. Rate of change of momentum in simple words, or rate of change of momentum of system, because we are talking about here system. So that is why 0 to, T naught initial time, it is written over here, to T final, okay, F external, okay, I write external over there, and dt. As you can read out clearly here, the meaning of this math, obviously the meaning of this line even means impulse I stand for rate of change of momentum of a system, because we talk about system here, and that is for a small interval of time. We put dt only and only means we are doing integration and differentiation only for a that much range of time, when we say limit time tends to 0. Very small interval of time, which is very, very small. Clear na? And in day-to-day life, in general real life, or you can say practical life also, we say that that particular person have an impulsive nature. Means, they are not have an anger issue. They have impulsive nature. What does it mean? They become angry so quickly. Right? You may be interacted till now or don't. But we have impulsive, not patience, I think, impulsive person in our surroundings. Okay, so keep a little distance from them, because sometimes they do something they're going to regret from whole life, and that is the, you can say, disadvantage of a impulsive nature, because they don't they are not something, they don't know if I'm going to do this, so I'm going, I'm going to face this for, you can say, in a large amount, but they don't know. So there are two terminologies: short tempered or impulsive, both. Right, both are the same thing, synonyms of each other. So that is what impulse is. Clear? What impulse is? You can say large amount of force applied to a short span of time. Very simply, you can understand, whenever your elder sibling or your mom scold you, so you hit the door like this, boom. So there is a large amount of sound coming. So that is shows a impulsive nature, or that is impulse. Got it? So that is basically the few examples you can find in day-to-day life as an impulse. Or sometimes you are irritated by your friend, so you just slap him or her. So that is impulsive nature again. Like in that, suppose you are in a irritated, in that state, you are not feeling good at that day. Particular thing happened with you, and someone starts giving you a lecture, like how how to be cool in this, and how to do this and how to do that. So inside your mind, you are going to say, just shut up, yaar, I'm done with the done today. And but the another person is keeps going on and on and on. So then you can do that, right? And that is also a impulse. Got it? So these are the real life example I'm giving you impulse. Okay, so impulse and everything done. Okay, so that is, I mean, momentum, linear momentum, we know what it is. SI unit we done already. Momentum of a system of particles we already know. Nothing we need to do, just the vector summation and this impulse. So now this is vector product of two vectors. Why it is necessary and why we learn this thing? Because in the coming slides or in the coming pages, we are going to use this simply. Angular momentum, angular displacement, angular velocity, everything can be related with the linear, or you can say multiply with the radius. So we need to just quickly you can say revise this thing. So vector product of two things, a particular product or a type of product of vectors in which the, you can say, obtained quantity or in which the resultant thing is also a vector. So R A cross B, A B sine theta. We can also derive the formula for the cross product of the two vectors using the determinant product. So what it is means, if we have a two vectors, that is very easy to understand. Okay, if we have two vectors, one in this direction, another suppose in this direction. So whenever you have a vector product, use your right hand thumb rule. What is right hand thumb rule? Make the four fingers in the direction of a first vector and rotate into the direction of the second vector. So in which the direction your thumb is going to given, automatically that is the direction of the third vector. How can I explain this? See, okay, just give me a minute. Suppose there are two vectors A and B, right? Clear na? So I can do this. I can rearrange this and I can make this vector in this way. It's my choice. I mean, I can shift vector without changing the direction or magnitude altogether. Okay. So now you can think the A vector is, whatever I'm going to do, it is going to be reverse in the direction of yours. So suppose A vector in this direction throughout the wall, right? And I'm going to rotate anti-clockwise. Where is my hand? Yeah, in this way, clockwise, because that is going to be into the paper. So I'm going into the direction of yours. So the thumb is going to into the upper direction. Clear? So on this same thing, the third vector is going to be somewhere in this direction. And you can now automatically see that all the three vectors are perpendicular to each other. Got it now? Clear? So whenever there is a vector product and you need to find the direction of a third product, because in few questions you going to, so you can see that that is in the x direction, that is in the z direction. If you can say that that is a z, negative of z, okay, because positive of z we can draw here, positive of z we can draw here in this way, and that is in y direction. Clear? So automatically you can see that it is in this way. If I can draw this kind of thing, just a minute, this is a or now one vector, and okay, just a minute, or this is your second vector. Okay, so automatically the, according to the right hand thumb rule, now this is vector, but you cannot rotate in this way, right? Because it is going opposite. So you need to do this way, and again the initial, or you can say again the obtained vector is into the upper direction. Why so? Because in this way the first vector is going to be, and instead of your side, now the second vector is my side, away from the plane of paper, right? So obviously you want to do this, but you cannot move your hand in this way. Automatically it is going to be given the same thing. So first vector in this direction and it is coming out of the plane of paper. So I rotate my four fingers out of the plane of paper, and again the thumb is in the upper direction. So here at it is also in this way. Got it? In this direction, in this direction, in this direction. Again, you can see that now instead of negative z, here my x is in the negative direction because it is going in this direction towards the negative side. If I can pick this origin, so the obtained vector is y, positive, and this is again in the positive z direction. Clear? So only you need to learn right hand thumb rule. So this is your formula, and we can also find with the help of a determinant. What is a determinant? That is a determinant. So if we need to find the A cross B, so A cross B is very easy. One thing you need to state, whenever there is a x component or I component, so in I component you never ever going to see the component of I. Clear? How we are doing this? Whenever we are finding I component or x vector, because this is suppose resultant vector. So this resultant vector beta, but Rx, Ry, Rz. Clear? How you can write resultant vector? Rxi plus Ryj plus Rzk, isn't it? In this way you can write. So this thing is Rx, this thing is Ry, this thing is Rz. As simple as that. So to find Rx, how you can find Rx? It is also very simple. Hide this and this. Okay. Now do the cross multiplication. The cross multiplication you need to do by and cz, and bz is subtracted. I mean this cross multiplication first and then subtract in this. So one thing you can find here, this is if you're doing in a from left to right, so you need to apply negative. Okay, basically this r is r of xi minus of r of plus of r of yj plus of r of zk. So one thing you need to notice here in this determinant, instead of taking y, we putting negative here. Why? So because then you only can do this from left to right. If you are doing this, so you're going to find this thing. Okay, so we are going to put negative here, and that is why we are doing. One way also you can understand this direction problem easily. I already told you maybe in the previous classes, but still if you don't know, so it's okay too. Just you can see this, and that is very general and very important to find the direction. This is I, J and K. Whenever you are going to do the clockwise motion, so clockwise motion gives you positive sign. In vector product, I you can find J cross. Okay, wait a minute. As you can see, I, J, K, right? And we know in vector product we have A or R is a vector which is A cross B, and that is A B sine theta. So 2-3 things altogether is going to be cleared out here. First, in vector product, if we are multiplying itself, R cross, not this, A cross A. So A cross A is going to be automatically 0. Why? So because theta between them is going to be 0, and sine 0 is 0, right? Clear this thing? So using this analogy, we cannot get I cross I, J cross J, and K cross K 0. Simple thing, first thing. So automatically if it is 0 means I cross I, J cross J, K cross K 0. So J cross K gives me I, but only it gives me positive I, and sign it is going to be positive if I'm doing in the clockwise. As you can see, J cross K is I. And how you can see that? From the previous. Clear? in this way we can find the negative. So you can see that I do this x cross j and get positive of y. X cross j, I mean this k. So when I do this negative anti-clockwise, so either I need to put this negative sign or either I get this. Okay, what I'm saying, stick to this. I am finding positive of y, but only and only when I do this x cross j. Clear? Clear na? So if I am multiplying this both with the negative sign, so what I can do? Is this clear? Clear this one? Clear na this one also? Okay. So now here you can see, if I multiply, this is, you can write in this way also. Just a minute, beta. And z, that is y prime. Okay. So you can see automatically whenever we are multiplying or doing cross product in a anti-clockwise, x to k or x to z, I get negative of y. Got it? And whenever I am doing with x to y, so I can get positive. So that is very important. I, or you can say j cross k gives me I. In the same way, k cross x give me y. In the same way, x, which is I, cross j gives me k. So what does it states, or what does it gives us? The meaning of this is very simple. The direction of vector product whenever we do with this diagram, anti-clockwise we can get negative, and whenever we do clockwise we get positive. Clear? So I can make a small note here. We get for clockwise rotation, for clockwise product or rotation, we get positive. We get positive vector product. Okay. And here I can, for anti-clockwise, the second thing, for anti-clockwise product or rotation, in vector product, we get negative result or negative resultant vector. If you just take and understand this, so you never ever going to get this positive negative confusion. One more thing you can understand, as we know this is r rxi ryj plus rzk. Okay, if you are finding this thing, like in rz you can get z anywhere, so you are doing some mistake. As you can see, in rz there is no z component, in y there is no y component, in x there is no x component. Clear? So what I am saying, in determinant or in finding a cross b in determinant thing, if you get x component in the rx vector or y component in the ry vector or z component in the rz vector or anything, a z, a x, a y, b z, sorry, bx, by, bz, any particular component, means if you get the same component in the same, you are doing some calculation mistake directly. You don't proceed further. And in direction wise, stick to this, or if you need to find the direction, so you can go for a right hand thumb rule. Clear? That is enough for this, you can say, vector product. One thing also, if you need to prove two vectors are parallel, so if the cross product between two vectors is 0, so that is parallel. And if you need to prove, you can say the two vectors are perpendicular, so you are going to prove A dot B, then A dot B is going to be 0, because A dot B is AB cos theta, and cos theta is 0 at theta equals to 90 degree. Okay, so beta, then A dot B is 0, so that is second. Okay, I can erase this thing and automatically write same thing, parallel vector. That is parallel vectors. So if you need to prove, so you can do that, and that is perpendicular vectors. Okay, clear this thing? Got it now? So if you need to prove, like prove they two vectors are parallel, so find the vector product in between them, and if it is 0, so obviously they are parallel. If you need to prove that two vectors are perpendicular, find this A dot B or cross dot product, so you can automatically. Got it? So now related to this vector thing, we have a question, I guess. Wow, I just got this is yours. So A is given, B is given. If C is a vector such that A dot C equals to C, which is C minus A is given to you, and the angle between A cross B and C is 30 degree, then A cross B cross C you need to find. Read this question again and then try what it is given. First of all, you need to find A cross B. The moment you can find A cross B, you can find the magnitude of A cross B, and there is a magnitude of C minus A also given. Yeah, C minus A magnitude is given, and then C minus A square you can do, and you can find the relation between C square and this thing, and then you can find A cross B cross C, because automatically you need to find C magnitude also. Okay, what I'm saying here, wait for a while, I can give you a little hint. Hint is A and B you know here. Okay, so find A cross B, and then magnitude of A cross B. Magnitude, I guess and I believe you know, that is nothing but, suppose it is R. Okay, so magnitude is, these are only two things, na? Yeah, I mean I and J. Okay, K is also there. So magnitude is going to be Rx square plus Ry square plus Rz square. So you need to find this first. Why I am saying? Because we need to find this A cross B and then cross C, but I don't know this particular thing. I know this CA magnitude. So when I square of this given thing, okay, suppose this is equation A, equation 1. So squaring of equation 1, that is simply C magnitude, A magnitude you can find from here also, and then minus 2CA, which is this, I mean 4 into 2, it becomes 8. So from there you can find the magnitude of C alone. Got it now? What I am saying, is this clear to you? From this equation, because we need to find this is the magnitude, this we already know, and this the magnitude you already know. So from this equation you can find the magnitude of C, and from this we can find the magnitude of A cross B. What we need to find? A cross B cross C. So A cross B cross C is nothing. You can put this as a R. Okay, basically the magnitude. So what it is? R cross C. But obviously you need to find the magnitude of R first. What we're finding from there, magnitude of C from there, and then sine 30 degree. Because the angle between A cross B and C is 30 degree. Got it? Do this. Okay. So I take a break over here, and you can also take a break, and you can do that in between the break. Exactly after 5 to 10 minutes, we are going to solve this if you are not able to. Okay. I already given a hint in this. So there is a 5 to 10 minutes break. You can go for washroom, drink water and anything, and find the solution if you want to. But if you are not able to find the solution in between them, 10 minutes, so I am going to explain. Clear? I already explained this thing. What is you need to do? Okay. Hello, hello, hello. Am I audible? Anyone did this or not? What is your answer? If you try so, first of all. Anyone got this or not, beta? What is the answer? Anyone? Anyone try or not? Out of 5 students. Bhuvana, Acha, Kanishka, Morish, Ashwin, Karthik. Okay. It's okay. What is, yeah. So as you can see, A cross B you can find in this way, I, J, K putting this, because in B you don't have K component, so you can put 0 over there, right? Then this is your I, J, K resultant vector, and then you can find the magnitude of resultant vector. 4 plus 4 plus 5, which is 3. Got it? So this is the resultant vector. A was already given, so when we multiply, or you can say when we square of this thing, so c minus a to the power 2, or you can say whole square, c square a square plus this equation you can get. And we already know a square, a magnitude we can get from this, because a vector is given somewhere, if I'm not wrong. Yeah, 2i plus 2j minus k. So again this is going to be 3. Why so? 4, 4, 1. 4 plus 4 plus 1, and that is 9, and that is 3. So again 3 to the power 2 is what? 9. Okay. So in this way we can get the magnitude of C also. Magnitude of A cross B we already get, which is R. Okay. Resultant vector, and this magnitude of resultant vector is again what it is, 3. So then A cross B cross C, AB magnitude of C, and then sine 30 degree. Sine 30 degree is half. So 3 into 1 into 1 by 2 is 3 by 2 answer. Is this clear? So that is your, in this way you need to find. Nothing, you can say big in this, nothing you need to take worry. The next thing is angular velocity and its relation between linear velocity. So I know, and I teach this thing so many times to you in between the class, I think in the last class also. So let's do this quickly. So what it is? Angular displacement. Whenever any particular person, any particular body, object, something, anything is moving in a circular motion, or is moving, or it is rotating around an axis, so that particular motion is occur in a circular manner. So in circular manner there is a relation between angular displacement, which is going to be done with respect to angle. Angular displacement is nothing but linear displacement, which is arc of length divided by radius r. Clear? And in the next previous class I know how I teach you this thing. Means again, if you want to, so simply it is very simple. If there is a, you can say this circle, okay, because this circle going to give you a better understanding. And there is, you can draw a axis. Suppose this is the center. So from this center, and there is almost, make this angle smaller angle. So as you can see, this angle, this small angle, which is theta. Okay, this is small angle theta in triangle OAB, tan theta. Okay, tan theta is what? AB upon OB. OB is what here? Radius. And AB is what? Perpendicular. And even from this you can find AB is perpendicular, or you can say length arc or linear displacement. Okay, linear displacement, that is S. Clear? So from this, from a small angle approximation, I already given to you this thing. From a small angle approximation we can do sine theta is going to be converted to cos theta to 1 for small angle theta. Okay, so then beta tan theta is going to be converted, which is sine theta divided by cos theta. It is going to be theta already. So from there you can get in triangle OAB, in triangle OA, in triangle OAB. Why should you, why should I give you this again and again? So you don't need to remember this, because I don't remember. I know this thing. Perpendicular upon base, right? Perpendicular here is AB, which is linear displacement S, or you can say length of arc L or S, or radius R. Got it? Is this clear now? So in this way we can find the relation or this thing, which is angular displacement theta, linear displacement upon radius. Unit, the important thing is unit. Unit is radian. Okay. Dimension, obviously m0, l0, t0, it is not, it is the dimensionless, and in vector form S is theta cross r. S, which is a linear vector, or you can say linear displacement, is nothing but angular displacement theta into r. Clear? So that is this thing. That it is a dimensionless. Theta is a number, and from this even you can find why it is m0, l0, t0 dimensionless, because this is length also, this is length also. So the length over length, it is a number purely. Okay, so don't say why this don't confuse in this, and even don't you can say misunderstood, like if it is a angular displacement, if it is a displacement, so it is going to be the dimension of a length. No, because angular displacement itself is defined in that way, that is division, or that is the, you can say, P by Q manner, and P and Q are the same thing. So obviously it is going to be the number purely. Got it, everyone? Okay, so then you can find in this way. Then after this thing, everything is easy, because using this equation 1, obviously R here is constant. Why it is constant? Because whenever we draw a circle, so R is going to be, or R is necessary, which is a radius, it is going to be constant. Suppose it is a 5 centimeter. So any particular point you pick from this O, it is going to be 5. It is not going to change. Clear? And why should I tell you this point? This is necessary because we are going to take derivative. We are going to find angular velocity and angular acceleration. Clear? Okay. So that is, you can point out equation 1. Okay. So that is, angular displacement is a vector quantity, simple thing, whose direction is given by the right hand rule. It is also known as axial vector for anti-clockwise sense of rotation. For anti-clockwise sense rotation, direction of theta is perpendicular to the plane outward and along the x-axis of rotation, and vice versa. What does it mean? Whenever we find theta or angular displacement, always we find in anti-clockwise direction. Anti-clockwise direction, whenever we are doing anti-clockwise direction, so the angle is going to be positive. Whenever we are doing clockwise direction, so the angle is negative or bigger angle. As you can see, here we find in this way, which is anti-clockwise. So theta is positive. And you can see, this is my, okay, wait a minute. This is my radius. Okay, radius vector is going up this side, and I am doing anti-clockwise, or you can say towards you, anti-clockwise in this way. As you can see, this is your first vector A, and this is your second vector B. So the moment I do in this, and then towards your, or you can say anti-clockwise, so the direction is going to be positive. Okay, so using vector terminology, or using vector, you can say right hand thumb rule, with which we can find the direction of a vector, automatically you can get the theta, which is S cross R or R cross S. Okay, in general R cross S, it is going to be upper side. That is why it is positive. The moment you can do in a negative sense. How you can do in a negative sense? Obviously you cannot do this and then reverse in a negative sense. So to get in a negative sense, do this. Suppose this is a positive vector, but right now you are moving in the direction, or you can say clockwise, or you can say in this. So that is going to be downward. Okay, means if right hand is again in this direction, and instead of moving in this way, it is going to be move backward. So in this direction, and then towards my side. The main thing is right hand over here. Means you can see it is moving in this way, and automatically my thumb, it is going to be downward when I move my side. Okay, so what does it mean? You can stick to this R only again. Okay, you can stick to this R again, but the moment you do a vector product of R cross S, suppose this is okay, suppose this is your S prime. Okay, this one is your S prime. So when you do theta, which is a vector, R vector into S prime, so automatically you can see that that is going to be the negative using right hand thumb rule, right? So that is written over here. For anti-clockwise, we can get theta positive. For clockwise, we can get theta negative. So one thing you can note down, for anti-clockwise rotation, anti-C means anti-clockwise rotation. Okay, theta is positive, and that is for clockwise. For clockwise rotation. Clear na this thing? why it is positive, why it is negative. So anything I'm not saying, just learn this thing and that. Everything you can find by yourself. Clear? Okay. Then 2 pi radian is 360 degree. That is very easy. Pi is 180 degree. Okay, as you can see, if I can draw in this way. So 2 pi radian basically is saying this. You again come or yes, beta. Yes, yes, yes. Ask Ashwin. Yeah, what do you want to ask?
Hello.
Yes, beta.
Sorry, sir. I accidentally pressed it.
Sorry?
I accidentally pressed it.
Okay, okay.
Sorry. Sorry for the interruption.
Alright, so what is this one revolution or 2 pi radian is 360 degree? As you can know, pi pi is basically 180 degree, right? So one revolution means if we are A and go in this way, anti-clockwise obviously, this, 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 and coming back to the initial point A. Got it? Again at A. So we can make one complete revolution or one complete full circle. So either you can say one revolution, one full circle, these terms or words you can hear one revolution, complete circle, or one revolution, full circle. Or you can say complete circle. Okay, or coming back to the initial point. So these points you can hear or you can read in a question. That means the angle is 2 pi, 360 degree, or 2 pi is in radian terminology it is 2 pi, in degree terminology is 360 degree, in revolution terminology is 3 revolution. Got it? Is this clear now? This is very important point because they never ever give you angle. They give you in this terminology 3 by 4 revolution, 3 by 2 revolution, and so and so. So 1 by 4 of revolution, how much angle it is? Tell me. Tell me, 3 by 4 of revolution. I'm saying asking only 1 by 4. Is this clear in your head or not? First of all, tell me this. Because 1 by 4 is very easy. See, understand this point. You understood what is a 1 revolution, 2 pi, 360 degree, right? So if I'm saying 1 by 4th of revolution. So beta theta prime, which is 1 by 4 of revolution, that is 90 degree exactly. 1 by 4 of 360 degree, 90 degree. So in numericals, they don't give you theta. They give in this terminology, like 7 by 2, 3 by 4, right? Obviously 7 by 2 means 7 complete revolution, so we don't need to worry. 1 by 2 we need to worry. Clear na? Got it? 1 by 2, 3 by 2, 5 by 2, or 3 by 4. 3 by 4 is again theta double prime, which is 3 by 4th of revolution, that is 3 by 4 of 360 degree, that is 270 degree. Nothing, because you just need to multiply 3 over there. Okay, and obviously if you know 1 by 4 only, so 1 by 2 is 2. Okay, 1 by 2 is 2 into 1 by 4. Got it? So that is 180 degree. In this way you need to just understand, not learn anything. You don't need to learn here anything. Okay, so this is the terminology. So angular velocity, the moment we know this relation, simple this thing, theta, or you can say angular displacement. Angular speed. I just erase everything. Angular displacement. Okay, angular displacement. And this terminology is going to help you a lot. Theta is r cross s, right? R can be fixed here. R is a constant vector, radius vector. Radius vector. So beta r is going to be constant because it is the radius of a circle, right? So r here is going to be constant. Okay. And I want to find angular velocity. So what I'm going to do, I'm going to differentiate this equation 1, this angular displacement 1. Okay. And automatically I can get everything. So angular displacement is, angular velocity is first of all the rate of change of angle with respect to time. Simply the angular displacement per unit time is defined as the angular velocity, or you can say rate of change of angle with respect to time is angular velocity. Clear? Suppose it is at a particular point P initially. After certain time it is reaches, the bed or any particular object in a circular manner, it is reaches at that particular point Q. So what is the angular velocity? So if a particle moves from P to Q in del T time, so omega, which is angular velocity, is going to be del T, and obviously instantaneous angular velocity limit tends to 0, so you can differentiate it d theta upon dt, and doing this you can get the relation also, what we're going to get in the next page. So average angular velocity is total angular displacement time divided by total time, theta 2 minus theta 1 divided by t2 minus t1. Unit is radian per second because the angle we can find in this way, and dimension is time inverse. Why time inverse only? Because radian, which is a ratio of two length arc upon radius, it is constant. Okay, so dimension is time inverse, which is same as that of frequency, because frequency is 1 by t, which is time inverse also. Okay, and that is why we can put angular velocity equals to 2 pi into f. Got it now? Okay. Where omega equals to d theta upon dt, and differentiating this r cross s. So r is constant. So what I'm going to do? Okay, so that is in vector or in magnitude wise, omega equals to rv. Simple. Clear, beta? That is, I just represent in, I think, second or third time. Moving ahead, vector form of v equals to omega cross r, where v is linear vector. Wait. This is wrong, because theta. I am always confused in this. See, theta we can define as over r, and you don't tell me, sir, you are doing wrong. This is my original relation. Okay, na? So from here I can get r cross theta. So then beta, everything is going to change, and v is omega r. Okay. So this is my equation 1, and differentiate this equation. ds by dt. R is going to be constant. So r cross d theta by dt. You can do that also. dr by dt cross theta, but this terminology, or you can say, but this thing, this second term is 0. Why? Because r is constant here. It is a radius vector, right? So when it is a constant, it is a radius vector. So that is v, and that is r, and that is omega. And then that is going to be slight change. V is R omega. And I think I need to theta equals to R cross S. Here I do a little mistake. So that is, here I need to put S. So just I can erase this thing. Angular displacement theta is nothing but S over R. Clear? Clear now, beta? So from this and from this you can do this. Okay. So vector form, velocity equals to linear velocity is angular velocity into radius vector, where V is linear velocity, R is radius vector, omega is axial vector, or you can say angular velocity, whose direction is normal to the rotational plane. Obviously the direction of it is going to be normal to the rotational plane. Rotational plane is this circle. Omega you can write also 2 pi by t and 2 pi by n, and here is frequency. Okay, that is important. This one is important, and this one is important too. I mean, all these 3 points, 5, 6, 7 is important points. Clear, everyone? Okay. Then acceleration, if we already know the angular velocity, so we can find the angular acceleration. So that is quite normal, important one also. The rate of change of angular velocity is defined as the angular acceleration. If a particle has angular velocity omega 1 at time t1 and angular velocity omega 2 at time t2, then alpha, which is angular acceleration, rate of change of angular velocity minus rate of change of time, omega 2 minus omega 1 divided by t2 minus t1. Then this is instantaneous at any particular instant when time tends to 0. So you can do d omega by dt or d square theta by dt square. Unit is radian per second because theta have some unit, and this dimension is m0 l0 t2 minus. If alpha is 0, that is important point again, for uniform circular rotation, for uniform circular rotation, either circular or rotational motion, alpha is 0. Why? Because that time in circular path omega is constant. What does it mean? If there is a particle is rotating in this way, in this way, in this way, so the angular velocity omega is constant, and omega is constant for uniform circular, or you can say rotational motion, or rotational motion is said to be uniform. Is this clear? Clear na this thing? So these are the few important points, nothing much. The average acceleration is again this omega 2 minus omega 1 divided by t 2 minus t1, important one. There is a relation between angular acceleration and linear acceleration. Again, we have velocity is r cross omega. This is my second equation on the, on this page, this page. Okay, you can use this is a second equation. So using this equation number second on that, again differentiate this equation second, so that is going to be dv by dt. R is constant, so again that is going to be 0. So r cross d omega by dt. Okay, and then we get d omega by dt is alpha, which is angular acceleration, and r is radius vector. So from here we can get linear vector, linear acceleration is nothing but alpha cross r, or r cross alpha. Okay, it is an axial vector whose direction is along the change in the direction of angular velocity, that is normal to the rotational plane, outward or inward along the axis of a rotation, depends upon the sense of rotation. Clear? So these are basically the properties. This is the important thing. I'm not going to prove, I'm not going to rewrite anything, but that is very, very important. I'm just going to tell you few important aspect of that. In linear, if linear acceleration is 0, means u is constant, and then you can say displacement is ut. This is from second equation of motion. As we know, S equals to ut plus half at square. For uniform motion, a is 0. Clear na? So then it is going to be. In a same sense, if angular acceleration is 0, so omega is constant. Sorry. And if omega is constant, so theta is going to be omega t. Okay. If linear acceleration is constant, it is not 0 then, constant. So these are the equation. S equals to u plus v divided by 2 into t, and acceleration is v minus u by t. V equals to u plus at, S equals to ut plus half at square, v square equals to u square plus 2as. And what it is, this is the very important, you can use directly, and you are going to find few questions on that. This is nothing but the displacement on the nth position. If there is n number of you can say points given, and you need to find the displacement on the nth position, so this is the relation. Sn equals to u plus a by 2, 2n minus 1. You can use directly. So this is for linear case, or you can say this is all the things for linear velocity, right? For linear motion. On the left hand side, whatever we see the equation, this is for linear or translation motion. Translation means in a single or straight line. And that is for, on the right hand side, whatever we are seeing, this thing, that is everything for circular or rotational motion. Circular or rotational motion. If acceleration is, or you can say angular acceleration is constant, so theta omega 1 plus omega 2 divided by 2 into time, alpha, which is omega 2 minus omega 1 divided by time. Omega 2 means final, or you can say after certain time, angular velocity is initial angular velocity plus alpha into t, where alpha is same as this angular acceleration. Okay. In this linear translation motion, we can find displacement. Here we can find angular displacement. So theta is omega 1, you can say initial angular velocity into t plus half into alpha t square. And then that is omega 2 square equals to omega 1 square plus 2 alpha theta. And theta for nth position, omega 1 plus 2n minus 1 into alpha by 2. Everything is same, remains same. Just we rewrite into the terminology or in the form of angular aspect. Nothing is going to be changed. Is this clear? This table itself is going to give you the clarity for lots of numericals, for lots of questions or hard complex questions. Okay, last 2-3 equations are going to be very useful. Clear, everyone? Okay, even this equations is important, these two. And these three equation is, you everyone know, equation of motion in linear motion or translation motion, or equation of motion in circular or rotational motion. So these three equation is well known for each and everyone, but the upper two and the below two, and the, you can say below one, you are going to use in important cases where the complexity of these numericals a little bit high. Okay, and these two is important. Clear, everyone? So you can think, or you can see, not think even, this table itself is very important. Clear na? Okay, so I think on the next page you have a question. Do that. A wheel initially at rest. Read this. Initially at rest means omega 1 or initial angular velocity is 0. Rotated with a uniform angular acceleration, the wheel rotates through an angle theta 1 in first 1 second and through an additional angle theta 2 in the next 1 second. So the ratio of theta 2 by theta 1. Find this. Very easy. Do this with this thing. This is the easy one. Hint is simple. Hint is use second equation of motion in circular motion. In circular, I'm not going to write even circular or rotational motion. Like theta equals to omega 1 t plus half alpha t square, something so and so. Okay, that equation you need to use. How to use? You think that. Okay, and after that we have one more question and then we are done for the class. Okay, and then we need to do the class assessment. Is this clear, Morish or Bhuvana or Kanishka or Atsya or Ashwin Karthik? What you need to do in this? You are from Brahman family, Atsya, right? Right? 3. Yes, the answer is 3. I'm asking something else than this. You are from Brahman family, right? No. Then why your father is roaming here and there shirtless? It happens, it's quiet. But you need to say, see, I'm being a boy, it's okay for me, but it's not okay if like Sushma ma'am and any other female tutor is teaching to you. Okay. So the answer is 3. Okay, what it is? See, that first, I mean, that is, she is laughing out now after understanding what I am saying. Cool. So that is C. C is correct. 3 answer. I mean, the ratio is 3. See, angular displacement in 1 second, theta 1. Because omega 1 is 0. Initially at rest, na? Initially at rest, so omega 1 is 0. So using this, theta equals to omega 1 t plus half alpha t square. So in first second, that is your theta 1. From theta equals to this, now again we will consider the motion from the rest and angular displacement in total 2 seconds. Theta 1 plus theta 2, 1 by 2, alpha 2. Because now time becomes 2 seconds, that is 2 alpha. So from this equation number 1 and equation number 2, because theta 1 is this, alpha by 2, and that is how you can write alpha. And theta 1 plus theta 2 is 2 alpha. So obviously when you put alpha 1 here, so you can get theta 2, that is 3 alpha by 2. So we need to find the ratio, that is theta 2 over theta 1, that is 3. Easy one. Got it, everyone? Clear? Is this clear, Bhuvana? Clear, beta? Yes, I'm asking to you. Okay. Okay, the next one is this. As its angular velocity increases, uniformly and becomes 60 radian per second after 5 seconds. The total angular displacement. Again, same thing. If it is increases and becomes 60 radian per second. So 60 radian per second is what? Angular acceleration, if I'm not wrong. Radian per second, right? Angular acceleration. It is omega 2. Find alpha and then find total angular displacement. It is radian per second. What you are going to do? Using v equals to u plus at in the same manner, omega 2 equals to omega 1 plus alpha t. You can find alpha first and then similarly you can find theta. And give me the answer. Everyone. Why you are not doing, Morish? And where are you looking this student? Ashwin Karthik. Did you get it, beta? This Kanishka. You are finding the answer. What it is? I mean, what is the answer? A, B, C, D.
Sir, am I audible?
Yes, you are allowed.
Sir, I'm trying, sir. Just a minute.
Okay. Hmm. And you, Bhuvana, what is the correct answer? A, B, C, or D? Tell me other students also. Acha says 150 radian means D, but I don't think so. I think that is C. Is this correct or not? You got also 150. And any other also? See, that is just a 30-second or max to max 1 minute question. Even not 1 minute. Okay. I don't know why you take that much time. Angular acceleration, omega 2 minus omega 1 by t. Everything we have in our hand. Okay. As you can write, given omega 1 is 0, omega 2 is 60 radian by second. You don't need to write this thing for MCQ. T is 5 seconds, right? So in this way you can find alpha. Yes, beta. I know you can think, see, it's okay. That's why I ask you. See, don't, yeah, don't confuse yourself in the maths, first of all. Just put the formulas easily and then do the maths. Alpha is omega 2 divided by omega 1 divided by t. So that is this. And automatically you need to use this equation. Omega 1 is already 0. So theta is nothing but half t square. We know alpha also. We know t also. Multiplying everything. So that is 25 into 6. That is 150. Clear na? This 6 means 1 by 2 into 12 into 5 into 5, which is 25. So that is 6 into 25, 150. Is this clear, everyone? So the correct answer is D. Got it? 150 radian. Okay, so in this way we finish this lecture. Finally, first lecture on time, or you can say after so many days. What we learn in this: linear of momentum of system of particles, vector product of two vectors, angular velocity and its relationship with angular velocity, or you can say linear velocity, and angular acceleration and the properties of angular acceleration and its relation with linear acceleration. On the next page, there is this link of your test. Open this. This is your class assessment test link. Okay. And there are 6 questions over there. Open that, do that, and if you find any difficulty, so let me know. Today you have enough time to complete and to ask if you get anything, if that is not done in the class or you are not understanding the question. As well as I attached homework too. Okay. So the homework is important too. Do that also. So I want to know this one query from you guys. At what time you are getting free after your school? Tell me, Vida. That is the perfect way. Try that also. Because you guys are not trying even. Tell me. You tell me, at what time you get free after your school? 5:30 to 7:30. Oh my goodness. Each. Morish, Ashwin, Kanishka, or Bhuvana. You also, guys? What your school curriculum do till that late? I want to personally know. They teach you Zumba or this some extra activity also. Then what you guys doing that late? And at what time you are going? 12 o'clock in the morning. At what time you are going to your school? 12 or what? 5 to 7:30. 9, 8 and when? 9. Oh my goodness. Kanishka is going 8. I personally want to know now what you guys do after 2 o'clock or 2:30 or 3:30 actually. 3 o'clock. Because the max to max time limit of any particular schools in north, in Maharashtra or anywhere other than this south region is 8 to 3. Max time I'm saying. Including the bus time. If you are going with the bus. So what you guys do or what your schools provide after 3 o'clock? Dance. What you are saying, dance or what? Extracurricular activity. Sports. What they provide? I mean, is there any provision like you can come free after filling a form, I want to go on time? No, sir, only class. Class for what? How many class you have in a day? 12. It's almost 8 hours. And you have 5 subjects. Right? I mean 5 main subjects in 11th class at least. So if 1 hour each class, 8 period. So 1 hour period or 8 period. 8 period for what, beta? PT, sports, extracurricular activity or what? How you can manage that long time? If my school timing is like this, I'm done with the school. I'm not going to school then. Okay. Ninth period, any subject? Oh my goodness, you have ninth period. Oh yes. Eighth period and eighth period, you have, I guess, six subjects and then two extra subjects, language and so and so. What? I think someone needs to tell the government of yours, like in higher order classes, I believe personally there is going to be, the school timing is max to max 6 hours. Half an hour for lunch, half an hour for prayer and everything, and 5 hours class. Or you can say three class, then break, and then two class, and then two class and break, and then three class. Max to max 6 hours. Five main subject. Sometimes it's repeat. Wow. Because see, obviously, if a 1 hour class is going to be given by the tutor or by a teacher, so you need to learn 2 hours. That is quite obvious. And you are preparing for your biology or for, you can say, for NEET or for JEE. So you are necessarily or deliberately need to join any particular extra classes like this, online, offline, anything. So you don't have time for your self-studies, isn't it? Because 9 hours in a day for school, then 2 hours for this. So you are not that, you are not have that time. You are not energetic. You are not have the time, because if you are indulge yourself 12 hours in a day, and at your age, I think 10 hours of sleep, so 22 hours there. So what you are going to do in 2 hours? Nothing. That is quite simple maths, right? Isn't it? Okay, beta. Try this. See, I'm not going to ask then after. But anyhow, you uh, find a time and you need to escape anything, or you need to figure out something, then only you can do something. Okay, so there is a class assessment. Open this, and first of all tell me, is this visible to each and everyone? And once you open that, so do that. Okay, there are 6 questions. If you find any particular difficulty in any question, so let me know. Meanwhile, I am also opening this because I need to see what particular question I have provided to you today. So there is a class assessment. Yeah. Okay, I think I need to just explain first, and rest you can do by yourself. Okay, just a minute. See, two identical discs of same radius are rotating about an axis, and they are moving in opposite sense. One is clockwise or another is anti-clockwise. Okay, so the discs are in same horizontal plane. At time t, the points P and Q are facing other as shown in the figure. Okay, P and Q in this one time rotation. In one time period t, rotation of disk is VR as a function of time is best represented by. So what particular function you think? See, at initial point it is going to be relative velocity going to be 0 at time t. At time t by 4 it is going to be 2, or going to be again 0. Okay, so the function a is going to give you the thing. Just a minute. Just a minute, I am explaining this because I think only I need to explain this. Still, if you find something else like that is necessary, So this is your question, and the snip in which I give you the question, the correct answer is this also. And how is this? Just a minute. So this is your first question. So we know time period T is, okay, capital T first of all. Capital T is time period. What is time period? Time period is basically time taken or time taken to complete one revolution. Time taken by body for one revolution. Okay, means if it is start from this, again coming back to this, so that is a time period. So we have three conditions over there. In this, V1 is going to be this, V2 is going to be this. So initially the relative velocity is 0 because both are going to be in same direction. And what is relative velocity? V1 minus V2. Clear? Clear na this thing? So initially at this particular point, that is also necessary to just a minute. Okay, I explain in this way. I mean, first of all, I can give you this, so automatically you can get this. This is the proper written explanation because I can't draw that much. As you can see, initially the relative velocity is going to be 0. Clear? At time t equals to 0. When they reach at this particular position, means this is quarter of the portion. So time t, so relative velocity is going to be added up. Why so? Because one velocity is going to in this way, another it is in this way. So you can say that V1 is negative of V2. So relative velocity, which is V1 minus V2, it is going to be 2V, and that is going to be 2R omega, as simple. In a third sense, at this particular point, T by 2, starting from this, coming to this, that is half time period. Again, it is going to be 0. Why so? Because it is same again in the direction. So again, relative velocity is 0. Or initially also it is 0. Clear? So at initial point, at this second point, at this third point. Third point, it is going to be 0. Second point, it is going to be maximum. And then at the relative velocity is 0 at initial point. So that is why initially it is 0. As you can see, this function only explained. Initially 0. At t by 2, at t by 4, it is going to be maximum. At t by 2, again 0. At t 3 by 4, again maximum. Again complete one cycle. Again complete reaching this particular first position, 0. Got it? That is why A option is correct. Any other option, what you can see on that test, it is not correct. Clear, everyone? Okay. Other than this, if you find any particular question which is not done by you, okay, second question, kinetic energy is half mv square, and V you can put R omega. And then you can find omega square, which is something value, and you can find equation, I mean, you can use third equation of motion, omega square minus omega naught square 2 alpha theta, from where you can find omega naught or alpha. Or this third question is torque force into R, and so and so. And fourth question is easy, theta is alpha t square. Fifth is easy, sixth is easy, vector product, do by yourself everything. This question I need to explain because I know I need to explain this. Each other question is easy, try that. If you don't find it, I mean how to solve, so you can ask me in the next lecture. Clear?